My name is Noe Flores Amonia. I study petrochemical process engineering at Universidad Autónoma de Tamaulipas, and today I'm gonna talk about ammonia. Ammonia. Definition. Ammonia is a compound of nitrogen and hydrogen with the formula NH3. The simplest nitrogen hydride ammonia is a colorless gas with a characteristic pungent smell. Ammonia, either directly or indirectly, is also a building block for the synthesis of many pharmaceutical products and is used in many commercial cleaning products. Natural occurrence. Ammonia is a chemical found in a trace quantities in nature, being produced from nitrogenous animal and vegetable matter. Ammonia and ammonium salts are also found in small quantities in rainwater, whereas ammonium chloride and ammonium sulfate are found in volcanic districts. Raw materials. As the raw materials, we have the petroleum and natural gas. These ones are the preferred raw materials for the production of ammonia, but coal, naphtha, and fuel oil are also used. 77% of the world production of ammonia uses natural gas as raw material. Uses and benefits. Ammonia as a fertilizer. About 90% of ammonia produced is used in fertilizer to help sustain food production for billions of people around the world. The production of food crops naturally depletes soil nutrient supplies. In order to maintain healthy crops, farmers rely on fertilizers to keep their soils productive. Fertilizers can also help increase levels of essential nutrients like zinc, selenium, and boron in food crops. Industrial use. When used as a refrigerant and gas in air conditioning equipment, ammonia can absorb substantial amounts of heat from its surroundings. Ammonia can be used to purify water supplies and as a building block in the manufacture of many products, including plastics, explosives, fabrics, pesticides, and dyes. Ammonia is also used in the waste and wastewater treatment, cold storage, rubber, pulp, and paper, and food and beverage industries as a stabilizer, neutralizer, and a source of nitrogen. It is also used in the manufacture of pharmaceuticals. Process. The industrial synthesis is obtained exclusively by the method called Haber-Bosch. The process consists of the direct reaction between nitrogen and hydrogen gas. It's exothermic, so an excessive temperature increase does not favor the formation of ammonia. However, the formation speed of NH3 at room temperature is almost null, a very slow reaction since it has a high activation energy, a consequence of the stability of N2. Use a catalyst as iron oxide that is reduced to iron in the H2 atmosphere. And it works at high pressures since this favors the formation of the product. Here we have a diagram of the method of obtaining ammonia with the catalyst, the pressure, the temperature, if the gas recycled, and the percent of transformation. As we can see, we can obtain more ammonia with a activated iron catalyst of the method Cloud from France. In the next flux chart, we can see the process of obtaining of ammonia. The process of reforming with steam consists of the stages: A. Natural gas treatment. B. Production of H2 and N2. C. Synthesis of ammonia. And as we can see, our process is very complex and with very amount of steps. Feed of the purification of the process. At first, we have to remove the sulfur to avoid the poisoning of the primary reformed nickel catalyst. Signs: the distributing companies add sulfur compounds to smell it. Here we have the hydrogenation and adsorption. Then we have the reformed. The food for the reformers can be natural gas, LPG, naphtha, or refinery gases. Once the natural gas is adequate, it's subject to a steam reforming process, the cracking breaking of CH4 molecules, and the ratio of mixture natural gas water vapor is 1 over 3.3, which occurs in two stages: the primary reforming and the secondary reforming. Mutation. After the secondary reformer, the crude synthesis gas passes through two stages of mutation, where the carbon monoxide is transformed into carbon dioxide. The first in the presence of a ferrochromium catalyst, and the second in a catalyst copper. Purification. The carbon dioxide generated in the mutation section is removed from the gas stream by an absorption-desorption system with a solution based on a potassium carbonate, from where it is taken for sales as a byproduct. Methanation. Last stage for the purification of the synthesis gas is the current passes to the methanator, where the traces of residual carbon oxide are transformed into methane and water in presence of a nickel catalyst. It's the opposite reaction to the steam hydrocarbon reformation reaction. The ammonia synthesis. Previously, it goes through a cycle of compression. The reaction of obtaining happens at high temperatures and pressures. Later, a condensation process for the ammonia obtaining begins. Subsequently, the pressure reducing drums follow to reflow the process. As we can see in this flux chart, we can see that the feedstock of the reformation of primary and secondary reformation are the steam, air, and methane. The petrochemical complex in Mexico. The Cozolacaque petrochemical complex is located in the southern area of the state of Veracruz, approximately 25 kilometers off the coast of the Gulf of Mexico. The goal of the complex is to cover the demand for ammonia for agribusiness in the country. As we can see in this flux chart, is the process more simplified, where we can see that the first step is the desulfurator, and then the primary reformator, the secondary reformator, where it's fed by vapor, steam, and air. Then we have a remotion of CO2, the methanator, the synthesis reactor, and the refrigeration. we can see here the flux process of the petrochemical complex of Cosolacake, where we where they going to where they are going to almacenate all this ammonia and subsequently commercialize it. And that's all, folks.